Welcome to solverfy.
So for part A, we simply want to find the spring constant. We know that the period is going to be equal to 2 pi times the square root of the mass divided by the spring constant. So we can say that the spring constant is going to be equal to 4 pi squared times the mass divided by the period squared. We can solve and say that this is going to be equal to 4 pi squared times the mass of 0.0095 kilograms. And then this will be divided by the period squared, so 0.69 seconds quantity squared. And we find that the spring constant is going to be equal to 0.788 newtons per meter. This would be our final answer for part A. For part B, we want to find an equation for the displacement in terms of time. We know that the amplitude is 0.82 centimeters. And we know that the general equation will be x equaling a cosine of 2 pi times t, the time, divided by capital T, the period, plus the phase constant phi. We know that the initial position, x of 0, equals 0.82 centimeters times cosine of phi, and we know that this is going to be equal to 0.43 centimeters. So at this point, we can solve for phi and say that phi is going to equal arc cosine of 0.43 divided by 0.82, and phi is going to equal plus or minus 1.02 radians. Now, we know the graph is shifted to the right of the zero phase cosine. Therefore, the phase constant here must be subtracted. So it's actually going to be equal to the negative term. So we can actually just erase this. And again, because the graph is shifted to the right, this is going to be equal. This is going to be, the phase constant needs to be negative. So essentially, we can put all of it together and say that x, the displacement, will be equal to the amplitude 0.82 centimeters times cosine of 2 pi divided by the period of 0.69 seconds times t, the time, minus 1.0. And so this would be our final answer for part B. That is the end of the solution. Thank you for watching.